Hello students, am I audible, sir? Okay, welcome to IMS GATE Academy. I hope you are doing great. Good evening, Suresh, good evening. Chandu, now it is audible, I think. Okay, thank you. I think it is the right time, my dear students. You have to switch on your preparation. It is the high time for all the civil engineering and GATE aspirants, my dear students. As part of the GATE score booster, my dear students, I am coming live for transportation module and I am done with stopping side distance, that is geometric design related to stopping side distance, overtaking side distance, extra widening, valley curves, transition curves. So in this session, my focus is more on traffic studies, flexible payments. So whenever you are preparing for GATE exam, my dear students, geotechnical, transportation and also environmental, these three subjects along with engineering, mathematics and aptitude is very, very important. And remember, my dear students, you have to make a productive preparation. And IMS has come up with a free mock test series. Any student from India can download the mock test series and they can solve almost 750 questions where they cover all the topics of the respective subjects. In civil engineering, we have a very nice team, Ankit as well as Pratik. We will be handling the civil engineering subjects, and any kind of doubts, you are always feel free to comment in the comments box or in the chat box. So as part of GATE score booster, what actually GATE score booster is, in a couple of short duration, we are going to cover some problems, in turn touching all the topics, so that each and every student of a serious GATE aspirant will definitely undergo through very nice knowledge after this session. It's not only me, we are doing for all the branches from IMS GATE Academy. So it is very high time for the GATE aspirants, my dear students. So myself, Sandeep Adari, I have done my BTech from JNTU Hyderabad and MTech from NITK Surathkal with AIR 192 rank, my dear students. I have trained almost 10,000 students across the country until now. So today, I would like to discuss, most of the students might be asking me, sir, what exactly is transportation? When you design transportation, my dear students, when you talk about transportation, I would like to tell you one very important point is MX roads. Remember, my dear students, if you want to be good in transportation engineering, as you are aware of structural softwares like StatPro, ETABS or SAP or anything, MX roads has a very high advantage in the design of traffic and also in payment when you are dealing with MX roads. As a transportation engineer, if you are targeting MTech in transportation, your MX roads should be very good. Okay, my dear students? And coming to transportation, my dear students, I would like to add one important point. I have classified the topic into, one is geometric design, which I have been clear in the previous classes also. Geometric design and flexible payment, flexible or rigid payment. And we also have to go through traffic studies. And related to railway engineering and airport engineering, my dear students, my personal advice is go through the formulae part. When you are going through the formulae part, they will touch airport and also railway mostly on the formulae. Okay, so this is what transportation engineering is. So today's session will start with the beautiful problems, my dear students. We'll start with beautiful problems. So the first and the foremost question, can you quickly read the question, my dear students? For an axial load of 15 tons, he is telling axial load. This is a vehicle. For an axial load of 15 tons on a road, the vehicle damage factor. My dear students, they can ask you, Good evening, sir. Nikhil sir is one of the good faculty. Like Pragna sir is very good in fluid mechanics, and we are Nikhil Gaurav sir is very good in machines and measurements. Okay. Now, my dear students, we have VDF. What exactly is VDF? VDF is nothing but vehicle damage factor. So, in terms of standard axle, he is asking of 8 tons. Now, my dear students, you should understand what is vehicle damage factor. Due to the load, axle load, how much the factor it is going to impact the vehicle. That is nothing but the vehicle damage factor. Here you are clear that it is evident from the system or sorry from the question that axle load is how much, my dear students? Axle load is 15 tons, my dear students. Axle load is 15 tons. Now, my dear students, we also have a standard axle load. Is asking in terms of standard axle load is 8 tons. So, my dear students, is asking the VDF. What is VDF? Vehicle damage factor. Very, very simple, my dear student. Can anyone tell me? Can anyone tell me, my dear students? Thank you, Nikhil sir. Thank you. Can anyone tell me, my dear students, what is vehicle damage? So, here clearly given, my dear students, axial load is how much? 15 tons. And what is standard axial load, my dear students? Standard axial load is how much, my dear students? It is nothing but 8 tons. Now, my dear students, he is asking what is the vehicle damage factor? What is the vehicle damage factor? Now, vehicle damage factor is given by the formula axle load is 15 tons divided by standard axle load whole power 5. See, my dear students, what is the power? 15 by 8 whole power 5. It will be roughly 12.35. It will be roughly 12.35. My dear students, you can ask me now what is vehicle damage factor? You have to remember that vehicle damage factor is nothing but axle load divided by the standard axle load whole power 5 will give you the answer. Okay, that is a simple question, my dear students. Okay, now I would like to tell you, please read the question, everyone. My dear students, when you are preparing the GATE exam or whenever you are writing the GATE exam, the important point I would like to tell you is, you should not read the question thrice. You should read the question once and try to write the given data. So, whenever you have this time, you please mark whatever there, 24-hour traffic count. What is the first point? 24-hour traffic count at a road section was observed to be 1,000 vehicles. Was observed to be 1,000 vehicles. 1 second, my dear students. Is observed to be 1,000 vehicles. Okay. On a Tuesday in the month of what? July. Sir, here there is a 24-hour traffic and you have to understand it is in a month. If daily adjustment factor for Tuesday is how much, my dear students? 1.121. That is very important. Daily adjustment factor. Daily adjustment factor, my dear students, means for a day you are doing the adjustment factor. Because when we do traffic design, we have annual average daily traffic, like that we have different terms. So when they talk about daily adjustment factor, it was directly given in the problem. Daily adjustment factor is how much? 1.121, my dear students. And monthly adjustment factor is how much, my dear students? It is 0.913. Okay. Annual average daily traffic is asking the annual average daily traffic. That means he's asking annual average daily traffic, AADT. Can anyone solve the problem? My dear students, here when you talk adjustment factor is more, then you are assuming more number of vehicle. When you are assuming less, value less than 1, you are assuming less number of vehicles. That is common sense, I would. If something multiplied by more than 1 will be more than value. If something is multiplied by less than 1, it will be a lesser value, my dear students. So here, see, my dear students, I would like to add annual average daily traffic, that is AADT, annual average daily traffic is equal to, what is the observed traffic, my dear students? That is 1000 vehicles. So we have given observed traffic multiplied by daily adjustment factor. Daily adjustment factor multiplied by monthly adjustment factor. Multiplied by monthly adjustment factor. So my dear students, this is a simple common sense, my dear students. Based on the capacity factors, like adjustment factors, I should say, you are going to adjust the vehicles daily, monthly. When you are adjusting the vehicles in monthly or daily, my dear students, how it is going to affect the annual traffic, average annual daily traffic? This is no way related to transportation. It is basic common sense, my dear students. So here the observed traffic is given clearly in the problem that it is 1000. Okay, my dear students. So here we can write it as 1000 multiplied by, you have to take annual average daily traffic. So daily, how much is the daily adjustment factor? It is 1.121 multiplied by 0.913. Okay, this is monthly adjustment factor. So when you do this stuff, you will get a value of 1024 vehicles. And one more thing, my dear students, this also tries to understand if the traffic study has been done, if the road has to be extended or extra lanes has to be provided, what care they should provide for the traffic. Those things can be understood using AADT, that is average annual daily traffic. Is it clear? Quickly answer me, my dear students. Chandu, Alok or Chandu, Alok, can you quickly answer the? Okay. Now there is another beautiful question, my dear students. There is another beautiful question. For the hottest month of the year, when something is related to hottest means there is something related to temperature. You should understand that there is something related to temperature. For the hottest month of the year, the proposed airport site is, the monthly mean temperature of the average daily temperature is 39 degrees. See here, this is very funny, my dear students. He is telling monthly mean means he is taking the average of monthly and he is taking the average daily traffic also, temperature also. So in a day, he is trying to average it. On top of it, he is trying to mean the monthly. So he has given 39 degrees. The monthly mean of the maximum daily temperature. This is what maximum, my dear students. This is mean and this is monthly mean of maximum. Lot of difference is there, my dear student. One is maximum, another one is mean of average. Okay, from the given information, the calculated airport reference temperature. What should be the reference temperature? Can anyone tell me, my dear students? Can anyone quickly answer me, my dear students? Can anyone quickly answer me? See here, my dear students, I would like to tell you very important things. They want to understand what should be the temperature at the airport as a reference based on the average temperatures, mean of the monthly of the average temperatures, and mean of the monthly of the maximum temperatures. So whenever they have done this kind of stuff, we have a beautiful formula. The formula here is TA. Please write down, my dear students. Airport reference temperature, TA plus Tm minus TA upon 3. Okay. Now you will ask me, sir, what does A? A is nothing but average daily temperature. What is A? Average daily, mean of average daily temperature, my dear students. Now, similarly, if you ask me, what is M? M is nothing but the maximum average or maximum daily temperature. I've given that things also, my dear students. Is it clear? Is it clear, my dear students? So here, TA is the average daily temperature. TM is the maximum daily temperature. So he has taken TM as maximum. Again, my dear students, the formula is very important. Sir, how to remember also? Maximum will be always more. So you cannot usually, since I'm telling you cannot add maximum plus something. Take the average and find the difference between the maximum and average and divided by the 3 will give you the temperature or airport reference temperature. Are you getting me? How to remember the formula is very important, my dear student. You are taking the average, also the difference between maximum and average upon 3. So here, my dear students, average will be less. So that is 39. So my dear students, here I would like to tell you, average is 39, my dear students. Maximum is 48. So my dear students, average is 39 plus 48 minus 39 upon 3. Only for this part there is, my dear student. And this will be 48 minus 39 is 9. 9 upon 3 is 3. So it will be 42 degrees. Am I clear, my dear students? Am I clear? Am I clear, my dear students? Please respond. Chandu, are you there? So the answer here is 42 degrees. The answer here is 42 degrees, my dear students. Is it clear? Again, I would like to tell you, airport reference temperature, you can say airport reference temperature. You have to understand, my dear students, airport reference temperature is average plus maximum minus average upon 3. Simple formula, you will secure 2 marks in GATE exam, my dear students. You will secure 2 marks. So this is how you have to solve the problem. Okay. Now, this is also a beautiful problem, my dear students. The design speed of a 2-lane way road. The design speed of a 2-lane way road is 60 km per hour. And the longitudinal coefficient of friction is 0.36. The reaction time, my dear students, I would like to tell you very important thing. Remember, my dear students, in case of stopping side distance, the reaction time is 2.5 seconds. In case of stopping side distance, the reaction time is how much? 2.5 seconds. Am I correct, my dear students? If you can understand this, why I am telling, my dear students, luckily in the problem he has given, if they ask you for OSD, what is the reaction time, my dear students? If they ask you for OSD, what is the reaction time, my dear students? What is the reaction time? Anyone, my dear students, can you quickly answer? It is 2 seconds. My dear students, I am telling you very frankly, to make the question tricky, these are the standard values as per IRC, Indian Road Congress. You have to sometimes remember this value. 2.5 seconds in case of stopping side distance and 2 seconds in case of overtaking side distance. So, my dear students, the acceleration due to gravity is also 9.81 or 9.8 meter per second square. Now, my dear students, he has asked what is the intermediate side distance to the round off value. This is very important, my dear student. As I told you, my dear students, stopping side distance is nothing but lag distance plus It is defined as lag distance plus braking distance. What is BD? Braking distance. Am I clear, my dear students? Can you quickly answer me? Is this clear, my dear students? Okay. Okay. Suresh, now we have a question. They are asking, what is the intermediate side distance? See, my dear students, here when they ask you whether it is a two-lane road or a one-way road, is asking intermediate side distance. So, intermediate side distance, you can write here, my dear students, intermediate side distance is equal to twice the stopping side distance. Intermediate side distance can be written as twice the stopping side distance. And remember, stopping side distance can be taken as lag distance Vt plus V square upon 2GF. Okay? If it is gradient is given, plus or minus n is also added. So this is the formula for stopping side distance, my dear. Is this clear? Is this clear? So one more thing I would like to add you, my dear students. Here they have not asked SSD, they have asked IISD. So IISD is equal to what, my dear students? IISD is equal to twice the stopping side distance. IISD is equal to twice the stopping side distance. And remember, my dear students, when I show you in small letters, it indicates it is in meter per second. It indicates it is in meter per second. My dear students, if they gave you some kilometer per hour, to convert kilometer per hour into 5 meter per second, 1 kilometer is 1000 meter. 1 hour is 3600 seconds. So if you convert this, you will get a value of 5 by 18. What is the value of 5 by 18, my dear students? 5 by 18 is nothing but 0.278. 5 by 18 is nothing but the 0.278, my dear students. So here, if they gave you the question in kilometer per hour also, no issue, my dear students. You have to just convert into kilometer per second and apply this formula. So here they have given you how much, my dear students? Here they have given you velocity is 60 kilometer per hour. So when I talk here, so you can take here 0.278, how it came? 0.278 is nothing but 5 by 18 because V is given in kilometer per hour. Simple logic, amma. Why we have to convert into meter per second? Or simple thing is, here time is in seconds, my dear students. Time is 2.5 seconds. So you can directly take lag distance is equal to, you can directly take here lag distance is equal to 0.278 into 60 into 2.5. So the whatever the answer you will get, this is not the total stopping side. This is nothing but the lag distance, my dear students. This is nothing but the lag distance. Now, my dear students, when I ask you this is lag distance, we also have the another term that is known as braking distance. We call this as braking distance, and braking distance can be taken as V square by 2GF F plus or minus N. Now, my dear students, if they have not given any gradient, you can ignore the N and you can take it as 0. Here V square is how much, my dear students? V square you can directly do here also. Here when I talk about C, braking distance is V square upon 2GF. So here V square is 60 into 5 by 18 whole square. Acceleration due to gravity is 9.81 multiplied by coefficient of friction 0.36 because N value is now. Similarly, if you calculate lag distance, that is V into T, that is 60 into 5 by 18 into time is how much, my dear students? Time is 2.5 seconds. So when you add these two values, you will get a SSD. You will get the value of stopping side distance. So what is the stopping side distance we got? 81.07. We got 81.07. See students, if you want to understand, I have done in both the ways. because to constrain the train, we have done in both. Here it the 60 square, if you ask me, the formula they have taken is in kilometer. If they have taken in kilometer, they have to do the conversion. Okay. Now you have got stopping side distance is equal to 81.07 meter. Now in case of intermediate side distance in two-way road, it will be equal to twice the stopping side distance, that is equal to 2 into 81.07 meter. It will be 162.14 meter. This is the answer. This is the answer. Any doubts, my dear students? Any doubts? So here, if they ask you, what is the intermediate side distance? You can roughly write it as 163 meter. We are rounding off to the next answer, that is 163 meter. Any doubts, my dear students? Okay. Okay. Any doubts, my dear students, until now? Okay. I hope you have enjoyed the question. Now, the maximum number of vehicles, please read the question, my dear student. It is something like aptitude question, but makes sense. The maximum number of vehicles observed in a 5-minute period during the peak hour is 160. This is very important. What is given? He has given 5-minute period. How much, my dear students? Here the maximum number of vehicles is given. The maximum number of vehicles for 5-minute period at the peak hour or at peak hour. At peak hour is how much, my dear students? Is 160. Does it make sense, my dear students? So in 1 hour, how many 5 minutes are there? How can you know? So in 1 hour, if I do here, my dear students, in 1 hour, if I do here, you will have 60 minutes. And if I divide it with 5-minute peak, so in an hour, you will have 12 times 5. So the maximum number of vehicles of 5-minute period at peak hour means for 1 hour, if you calculate this, for 1 hour, it will be 160 into 12. 160 into 12 is 320. You can write it as 1920 vehicles. Are you getting me? For 5-minute peak, he has given for 5-minute period, during the peak, the maximum vehicles are 160. For 5-minute duration, he is telling the maximum number of vehicles is 160. So in a 1 hour, how many 5 minutes are there? 12 5 minutes are there. So the total number of vehicles will be how much in 1 hour? If we calculate, it will be 1920. If the total flow in the peak hour is 1000 vehicles, the 5-minute mean peak hour factor will be. The total flow is how much, my dear students? The total flow here is how much, my dear students? The total flow is 1000. So he is asking, what is the 5-minute peak hour? So here 5-minute peak hour can be written as total flow divided by peak rate volume. Volume is nothing but flow. You can write volume flow. So total flow is 1000 multiplied by peak rate flow. You have calculated just now, that is 1920. You will get a value of 0.52. So what I want to tell you here is, my dear students, the peak is nothing but the maximum. So maximum you are getting 1920 in an hour. You are getting 1000. So 1000 will be how much fraction of the peak that you will do? Peak factor means 1000 is the number of flow of traffic divided by the peak hourly factor. So you can write, sorry, not peak hourly factor, the peak flow rate or peak volume you can say. So 1000 divided by the peak volume will be definitely equal to 0.52. So given actual flow is how much, my dear students? It is 1000 vehicles per hour. It is 1000 vehicles per hour. peak 5-minute rate is 160 vehicles for 5 minutes. And if you calculate for 1 hour, it will be 160 into 12, that will be equal to 1920 vehicles. So when I thought what is the peak of volume is, or peak flow of traffic is 1920. So here you would understand the peak hourly factor is 1000 flow upon the peak hourly is 1920. If you do this, you will get a value of 0.5. So this is nothing but the peak hourly factor. Is this clear, my dear students? Is this clear? So I am going more on what topic, my dear students? I am going more and more on the traffic concept, because I sense there will be a question from traffic. So just go through that question for 1 minute. I'll give you 1 minute, my dear students. Just go through that question. Hello, my dear students. I hope you have understand this problem very clearly. See here, my dear students, the average free flow speed and the jam density observed on a road stretch, which is having a speed of 60 km per hour and 120 vehicles per kilometer. For a linear speed, this is very important, my dear students. This has a lot of significance. He is asking for a linear speed density. Are you getting, my dear students? That means the variation between graph, if you see the variation between speed and density, the graph is linear. How is the graph? The graph is linear. So he is asking the maximum flow on the road stretch. So here one is what, my dear students? They have given the speed as how much? Speed is 60 km per hour and the density is given as 120 vehicles. There are around 120 vehicles per kilometer. So, my dear students, we have a beautiful formula, that is Q is equal to KV. So traffic flow is defined as speed into traffic density. But he is asking what is the maximum flow. This is the formula for flow, not for maximum flow. So here we have to understand the proper concept, my dear students. Here you should understand the proper concept. So here, what is the maximum speed? See here, maximum speed is given as how much? 60 kilometer per hour. Okay. Maximum speed is 60 kilometer per hour. Okay. Similarly, if you see the question, my dear students, another important thing is maximum flow. The maximum density is also given as 120 kilometer per hour. The maximum density is also given as 120 kilometer per hour. Okay, 120 vehicles per kilometer. Density will be 120 vehicles per kilometer. Sorry, my dear student. Because units are very important, my dear student. Units are very important. So here it is 120 vehicles per kilometer. So when I talk here, my dear students, in case of maximum flow, it will be taken as average speed upon 2 into maximum jam density by 2. You can simply remember this formula. In the coming problems, I will show you the graph also, students, how we will be solving this, how this formulas came and all. So for now, the maximum flow is equal to 60 into 120 divided by 4. This is 15. 15 into 120 is 1800. So here if I take, it will be, what will be the answer, my dear students? One is kilometer per hour, maximum speed, and density is vehicles per kilometer. So the flow will be vehicle per hour. So 1800 vehicles are moving in an hour. Are you getting me, my dear student? This is a very important thing, I'll tell you. My dear student, speed is everyone know, that is distance by time. Density means how many vehicles are going to occupy in a unit length of road. So there are 120 vehicles in a unit length of road is per kilometer. So what is flow is how many vehicles are there in an hour flow. Means for in an hour, how many vehicles are going to flow in that road. That is what I would like to tell you. Okay. So the answer here is how much, my dear students? I hope you are clear. That is 1800 vehicles per hour. That is how much, my dear students? 1800 vehicles per hour. Is it clear? Is it clear, my dear students? Again, I am telling you, the maximum flow is given by the formula K into Vf upon 4. That is equal to jam density is how much? 120 into 60 upon 4. That is equal to 1800 vehicles per hour. This is the flow. Maximum flow, I should say. Flow vehicle per hour, density speed kilometer per hour, flow is vehicle per hour. Sorry, vehicle per kilometer. So simple words mein what I would like to tell you is, if this is a road, my dear students, if you take a particular junction, in this particular period of time, how many vehicles are flowing, that is called flow. How many vehicles are there in this unit length, that is density. Density is vehicle per kilometer length. This is vehicle per time. This is flow. And anyhow, you know about speed. So I don't want to explain you about the speed. Okay. Don't tell me again that what is the speed quantity. Okay. Whether it is scalar, all those things you are aware. Velocity and all. Now, please read this question, my dear students. Please read this question very carefully. This is another beautiful question. Actually, my dear students, if you know the you might have heard about binomial distributions and Poisson's ratio and probability. This kind of mathematics you have to apply. The traffic on a highway is moving at 360 vehicles per hour. The traffic on a highway is moving at what, my dear students? The traffic in a highway is moving at 360 vehicles per hour. You should understand it. How many vehicles are moving in a day per hour? 360 vehicles per hour at a location. If the number of vehicles arriving on this highway follows, this is very important, my dear student, follows Poisson's distribution, the probability that headway between successive vehicles lies between 6 and 10 seconds is. Means successive headway means you can say the distance at those times, that is 6 and 10 seconds. But he has used which distribution? Poisson's distribution. And he has told the traffic on a highway is how much, my dear students? The traffic on a highway is how much? The traffic on a highway is at a rate of 360 vehicle per hour. So what is 360 vehicle per hour? If you see this, my dear students, is it, Chandu, are you there? Alok, Chandu, Suresh, are you following, Amma? So when I say 360 vehicle per hour, what is vehicle per hour indicates? That is nothing but flow. That is nothing but the flow. So here, first of all, we should calculate the lambda. So my dear students, lambda is given as 360 vehicle per hour. Okay. But remember, he has asked the headway for 6 to 10 seconds. So he has clearly mentioned that lambda is time is given in seconds. So lambda I will convert 360 vehicles per second I will convert. That means divided by 3600. 1 hour is 3600 seconds. So here lambda will be equal to 1 by 10. That is 0.1. So if anyone asks you what is the lambda value, lambda is 0.1. How do you got lambda 0.1, my dear students? He has given the vehicle lambda is 360 vehicles per hour. We have just converted into seconds. 1 hour is 3600 seconds. Now, my dear students, here this is the problem. The probability distribution is given for 6 to 10 seconds. Here it is clearly given 6 to 10 seconds. Now the formula comes into picture. We have a formula, my dear students. Lambda T2 power 0, you can write here lambda T2 power 0 e power minus lambda T2 upon 0 factorial and lambda T1 power 0 e power minus lambda T1. Why? See here, you should understand one thing. You are taking from 6 to 10 seconds. Here T2 will be the 6 seconds and T1 will be the 10 seconds. If you solve this, you know already lambda, my dear student. Lambda you have already calculated is how much? 0.1. Lambda is 0.1 multiplied by lambda T2. T2 is how much? 6 seconds. Okay. You can write here 6 also. 0.1 into 6, my dear students, into e power minus 0.1 lambda T2. Are you getting me, my dear students? If you want to write here, I will write this equation. Lambda T2 power 0 e minus lambda T2 upon 0 factorial minus lambda T1 power 0 e power minus lambda T1 upon 0 factorial. Here lambda is very evident. It is 0.1 into T2 is 6 seconds e power minus 0.1 into 6 divided by 0 factorial. How do you got this formula is, this is a Poisson's distribution. Minus of lambda 0.1 into T1 is how much second? 10 divided by 0 factorial. E power minus lambda is 0.1 into T1 is 10. On solving this, you will get a value of around 0.18. On solving this, if you see here, my dear students, you will get a value of 0.18. So the successive headway vehicles between 6 and 10 seconds is 18. Is this clear, my dear students? Is this clear? Any doubts, my dear students? Can you please respond quickly? Any doubts, my dear students? Okay. Okay. Now, we have another important question, Amma. Please read that question. I'll give you 1 minute to study the question clearly. Please read the question carefully. Please read the question carefully, my dear students. Students, have you read the question? Okay. Now, this is a kind of flexible payment, my dear student. Or see, actually, there is a lot of concept related to the development length and also related to the RCC part here. Okay. There is a tie bar. Okay. There is a tie bar of 12 mm dia. There is a tie bar of 12 mm dia are to be provided in a concrete pavement slab. Are to be provided in a concrete pavement slab. The working tensile stress of the bar is 230 MPa. 230 MPa. This is the working stress you can write. Working tensile stress you can write. Or some people write it as sigma st. Okay. The average bond between tie bar and concrete is 2 MPa. Sir, my dear students, bond stress is nothing but the shear stress. So here he has clearly given tau BD is equal to 2 MPa. So this is what tau BD is. Am I clear? And the joint gap between the slab is how much, my dear students? 10 mm. The joint gap between the slab is 10 mm. So he is asking, ignore the loss of bond and the tolerance factor, the design length of the tie bars is. See, what do you mean by bond length, or you can write development length? See, if you have a bar extended here, what should be the bar extended so that it can stiffly hold the concrete? Okay, my dear student, how much the bar should be extended to stiffly hold the concrete, or to means if you provide good development length, you can avoid the means the bar tends to get loose, or the bar tends to means you can improve the gripping or improve the development length. Sorry, my dear students. Now here I would like to tell you one important thing, my dear students. Development length is clearly given. Development length. Okay. Development length is clearly given as 5 sigma st 4 tau BD. Okay, my dear students. Here you can take it as this one as tensile stress. Tau BD is the bond stress, and phi is the dia of the bar. Phi is the dia of bar. Okay, my dear students. So here, if you see this problem, he has clearly given 230 mm, and what is the dia of bar? It is 12 mm. It is 12 mm. So you can write here development length is equal to 12 mm into 230 Newton per mm square upon 4 into tau BD is how much? 2 MPa, that is 2 Newton per mm square. If you solve this, it will be around how much, students? It will be 4 3s are 12 to 1.5, it will be around 345. Am I correct or wrong? It will be around 345 mm. But remember, he is asking here development length will be on the, if you see the concrete slab, Okay, here you have this development length, and here also you'll have. But again, they have given another point here, my dear student. If you see here, 1 second, he is given the joint gap between the slabs is how much? 10 mm. The joint gap between the slab is 10 mm, my dear students. Is it clear? So what is the design length? So if they ask you, design length is equal to LD plus spacing, whatever the spacing, plus LD, 2 times. So here 345 plus is 10 plus 345. So 690, it will be around 700 mm. It will be how much, my dear students? It will be 700 mm. Is it clear, my dear students? I hope you are clear. Here you should understand development length plus spacing plus again development length. Spacing is given as 10 mm. Is this clear, my dear students? Can you quickly answer me? Is this clear, my dear students? Can you quickly answer me? Okay. Now please read this question, my dear students. Okay. Now see, students, I'll read the question for me. The uniform arrival and uniform service rates are observed on a approach road to a signalized intersection are 20 and 50 vehicles per minute. What, sir? The uniform arrival and uniform service roads on a approach road are 20 and 50 vehicles per minute respectively. For this signal, the red time is 30 seconds and the effective green time is 30 seconds and the cycle length is 60 seconds. He has given effective red time, effective green time and also cycle length. Assuming, what is cycle means? The time gap between the red and the green will be taken as cycle length. Assume that there is initially there are no vehicles. Assume that initially there are no vehicles in the queue. The average delay per vehicle using the approach road during a cycle length. So he is asking what is the average delay per vehicle. Means here you should understand, my dear student, you should understand the average delay per vehicle using the approach road during the cycle length. Again, I read the question for you. They have given you green time, effective red time and cycle length, and also they have given you that there is no vehicles in the queue and they are asking average delay per vehicle using the approach road. Okay, so but he has given uniform arrival and uniform service rates are observed for a signal intersection are 20 vehicles per minute and another one is 50 vehicle per minute. So here they have given you the flow. Are you getting, my dear students? Are you following? Can you quickly respond, my dear students? Okay. So here the effective green time is given as 30 seconds, my dear student. So I represent the effective green time as CI. What is the effective green time? The effective green time is given as, the effective green time is taken as 30 seconds. Similarly, my dear students, the cycle length is also given as, 60 seconds. Okay. Now, nominal flow or normal, so not nominal flow, normal flow. Under normal conditions, the flow of traffic is 20 vehicles per minute. Okay. And if you see uniform flow or uniform service rate means that is nothing but saturation flow. That is nothing but what, sir? Saturation flow. That is 50 vehicle per minute. That is 50 vehicles per minute. So normal flow is how much, my dear students? Normal flow is 20 vehicles per minute and saturation flow is 50 vehicle per minute. Now he is asking what is the delay? What is the delay? So here when I talk about delay, he is asking delay. So here we have clearly showed you CO is nothing but the optical cycle or cycle length. Sorry, not optical cycle. It is nothing but the cycle length. You can write it as CO. So here you can write the formula. You can write the formula. What you can write is di is equal to, my dear students, di is equal to C naught by 2 1 minus Gi by C whole square upon 1 minus Qi upon Si. What is Qi upon Si? Qi is nothing but normal flow. Si is nothing but the saturation flow. So you can write here, you can clearly write here, my dear students, C naught by 2 into 1 minus Gi by C naught whole square upon 1 minus Qi upon Si. So this is the delay formula, my dear students, which I have written there. Okay. So here when I talk about this, some people, we talk CO as what, my dear students? This is the, 1 second, my dear students. Here what I would like to tell you here is, delay is given by the formula C naught by 2 into 1 minus Gi upon C naught whole square by 1 minus Qi upon Si. What is Qi, my dear students? Qi is nothing but, what is Qi? Qi is nothing but, what is Si? What is Si? Qi is nothing but saturation flow. Saturation flow. What is Qi? Normal flow. What is Gi? Effective green time. Effective green time. What is CO? Optic cycle length, you can write. Cycle length. So here if you see the green delay formula, di is equal to, what is the optical cycle length, my dear students? Not optical cycle, sorry. What is the cycle length is 60 seconds. It is 60 seconds divided by 2 upon, I'll write 1 minus Qi is how much? That is normal flow, it is 20 upon what is satural flow? It is 50. 1 minus 20 by 50 upon 1 minus green time, effective green time is 30 upon 60. So what is the answer you can get? 60 by 2 is 30. 30 into 0.5 is 15. 15 divided by 30 by 15 divided by 0.6. 15 divided by 0.6. It will be equal to around 25. So you can say the delay is, sorry, whole square is there, my dear students. Here whole square is there. So actually it will be, 1 second, my dear students, small error. So if I take here, sorry my dear students, here if I take delay is equal to 30 into 0.25, because it's 0.5 square, here also square is there, upon 1 minus 20 by 50. Okay, 1 minus 20 by 50 is, this value will be how much, my dear students? This value will be how much? 30 into 0.25. That will be equal to 7.5 divided by, this is 0.6. Okay, so you will get a value of 12.5 seconds. So if they ask you what is the delay is nothing but 12.5 seconds. 1 second, my dear students. I will clearly explain you. Di is, the formula is di is equal to C naught by 2 into 1 minus Gi upon C naught whole square upon 1 minus Qi upon Si. What is Qi, my dear students? Qi is nothing but normal flow. Qi is nothing but the normal flow. Si is nothing but the saturation flow. SI is nothing but the saturation flow. And GI is known as effective green time. GI is nothing but the effective green time. And CE naught is nothing but the cycle length. So please remember, my dear students, by mistake, if you forgot these two, entire problem will be wrong. So here DI is taken as cycle length is 60 by 2 upon 1 minus GI is how much, my dear students? 30 by 60 whole square upon 1 minus 20 by 50, which I told you 7.5. One second, students. Okay, that will be equal to 7.5 divided by 0.6. That will be equal to 12.5 seconds. Any doubts, my dear students? So you have to remember the delay in formula, this one. Clear? Now, my dear students, please read this question. I'll give you a time, okay, of 1 minute. Please go through this and I'll discuss the problem, okay? I'll give you 1 minute of time. Please read the question carefully, my dear students. Now, my dear students, I hope you have read this question. Now see, important question, my dear students. On a road, the free speed was 65 km per hour. On a road, the free speed was how much? 65 km per hour, my dear students. And the space headway jam density is, 6.25 meter. What is the maximum flow which could be expected on this road? And I told you clearly, my dear students, that I will explain you the important part here. Now, my dear students, whenever you are reading, my dear students, the graphs makes a lot of sense. When a graph is drawn between mean speed and density, the graph varies linearly. That's what I would like to add here. That graph, I would like to tell you, the graph varies linearly. Are you getting, my dear students? So, you should have an idea how the speed and density is going to vary. Remember, my dear students, the speed and the density is going to vary linearly. That's what I want you from this. Okay, we'll talk about maximum speeds, maximum density and all, jam density and all in the other slide. And if you see the mean speed and the flow, remember, my dear students, here the flow is important. At which point the flow is maximum? Are you getting, my dear students? At point C, the flow seems to be maximum. And if you see, the density is maximum at zero velocity. And if the density is more, or if the speed is maximum, the density is zero. So that kind of variations you should understand. And if I draw the graph between flow and density, here this is very important. Now flow and density graph is looking in this way. Now, my dear students, I have a very important question for you. Sir, here it is varying linearly, here it is also varying parabolically. And here also the graph is varying parabolically. Am I correct or wrong? Now, when I see the diagram, one is speed and density. The speed and density varies in a linear way. The speed and density varies linear way. The speed and flow varies parabolic. And the flow and density varies parabola. Now here I have a question asked you, my dear students. Can you quickly answer me? Can you quickly answer me, my dear students? I want a very important point. If the speed is maximum, the flow is zero. If the speed is at half, if the mean speed is half, then the flow is maximum. So these kind of observations are required, my dear students. When the speed is zero, density is maximum. So here speed 0, or you can write speed 0, density maximum. Speed half, flow maximum. So these kind of observations you should write. Are you getting me? So please write down this point, my dear students. When speed is 0, density is max. And when speed is half, pre-mean speed or mean speed, when mean speed is half, or you can say at half of the mean speed, the flow is maximum. At half of a mean speed, the flow is maximum. Sir, why I am stressing these graphs is, I am frequently seeing a question from this, my dear students. And similarly, you can understand the flow is maximum when density is half. The flow is maximum when the density is half. Okay? The flow is maximum half of density. So you can understand, my dear students, how that formula came. You can understand when flow is maximum at a half of density and flow is maximum at a half of speed. So that is the reason it is taken kg by Vf upon 4. Are you getting me? This question. How this formula maximum flow is coming, this is the one which we have discussed. Is it clear, my dear students? Now, this theory I would like to tell you more importantly. This we call it as Greenshields model, Amma. This Greenshield model. My dear students, here I would like to tell you very, very important things. Here, if I take the mean speed as Vf, and if I take here as the K, that is maximum density as jam density. Now, my dear students, if you take here, the flow is maximum. Okay, that's what I would like to tell you. So, for this, according to this linear method, we have given an equation. U is equal to, you can write here, U is equal to free mean speed minus UF, you can write here, UF into kg into K. This is the basic equation for speed. How you got, my dear students? If you see the graph here, by means basic interpolation. So the speed is going to reduce by part. Initially it is at UF. How much it is going to reduce? That is nothing but the UF into maximum value is how much? UF, and at that place there will be some K value divided by maximum jam density. So, my dear students, if I talk here, what is traffic flow? Traffic flow is nothing but KU. Okay. Now, I can write flow is equal to K into UF minus UF upon Kj into K. Is this clear, my dear students? Is this clear? So, when I write here, the flow is maximum. First of all, for any function to be maxima or minima, when you do bending moment shear force also, why do you say that bending moment is maximum? When do you say that bending moment is maximum? When shear force is 0. Why shear force? Actually, the funda is the differentiation should be 0. Luckily, the differentiation of bending moment is shear force. That is the reason you are telling shear force is 0. Similarly, if I do here, to get the maximum density, maximum flow, you should write dq by dk is equal to 0. Okay. Now, if I write here, Q is equal to what, my dear students? Q is equal to K into UF minus UF into K upon Kg. This is the Q equation. Now, dq by dk will be equal to what? If I differentiate here, UF minus 2K UF upon, because K square integration is 2K divided by Kj is equal to 0. For flow to be maximum, we are differentiating it to 0. So, if I take here 1 minus 2K by Kj is equal to 0, because UF is common and it will go. So, you can write here, when Kj by, 1 is equal to 2k by kj, or you can write when k is equal to jam density by 2, when density is equal to half of jam density, when density is equal to half of jam density, you can clearly say that flow is maximum. This is another derivative part of it, my dear students. Is this clear? Is this clear, my dear students? Similarly, if you want to do for speed also, we will do. 1 second, my dear students. Here you have written Q is equal to what, Amma? Q is equal to K into UF minus UF into K upon Kj. Okay. Now I can write in case of dou Q by dou U. Means in respect of speed. I want in speed. Yes or no? So if I do here, you will again, you cannot do in this way, my dear student, because it will be 0. That's what I would like to tell you. 1 second. If you do in this way, because flow will be maximum, you are telling. But simply you know, you simply know, my dear students, what is free speed at a, if you want to know the velocity, velocity is given by UF minus UF into K by Kj. So if I substitute here, K is equal to UF minus UF into K is half of kg for flow to be maximum. Just now you have derived it. Okay. So kj cancel. UF minus UF by 2. So when velocity, when you can say when the velocity is half of the free mean speed, okay, you can say that flow is maximum. Sir, I have substituted these values in the velocity equation. And how this velocity equation came, my dear students? It is as simple as that, Amma. We have drawn a flow graph between velocity and density. And if you have seen here the maximum velocity, here the density is 0. So from this we have done interpolation and we have done the interpolation Vf into K upon Kj will give you the velocity at different densities. So that from generalized equation we have derived that. I hope you are clear. Remember, my dear students, we have a very beautiful things here. What is the beautiful things here we have learned is speed density. 1 second, students. If I see the graph between speed and density is linear. So you should write the graph between speed and density is linear. Similarly, if you see the graph between speed and flow, if I see the graph between speed and flow, this is speed and this is flow, and the graph will be like this. Okay, at half of the speed, the density is maximum. Similarly, my dear students, if I see the graph between flow and density, if I see the graph between flow, if I see the graph between flow and density, it will be at half of the density, flow is maximum. If you want to see all the graphs at a time, you can write here speed, density. Speed density, actual graph is this one. Speed flow. The graph is linear. So in this, speed flow. So here These are the three things, and remember the maximum flow will be at half of density and half of free mean speed. If you can remember this equation and also velocity at any point, means at any speed at different points at different densities, if you can understand this equation, K by Kj, any problem can be solved. This is 100%, my dear students. Now, sorry students, see. Here, actually, in the problem, they have given jam. First of all, we should understand what is jam density. Okay. I have given you the entire insight, Amma. The jam density is given as per meter. See, if you just find it for kilometer or, okay, 1000 divided by space headway. Space headway is given as 1000 divided by 6.25. You will get the jam density. Thus, you have to remember that jam density is equal to 1000 upon space headway. You will get 160 vehicle per hour, vehicle per kilometer. I told you density is per length, flow is per time duration. Is it clear, my dear students? Now, what is the maximum flow? Maximum flow is nothing but jam density by 2 and free speed by 2. 2 2s are 4. So, here jam density is given 160 and free speed is given as 65 divided by 4. Okay. So, this will be equal to 40 and you can write it as 2600 and the answer is A. Okay. Now, see students, here the free speed is given as 65 km per hour and space headway. Remember here, space headway is given as how much, my dear students? Space headway is given as 6.25 meter. Okay. Now, jam density is equal to 1000 divided by space headway. 1000 divided by space headway is equal to 1000 upon 6.25. If you solve this, you will get a value of 160. Now, clearly he has given, my dear students, the free speed is how much? 65. So, just now I have derived that U max is equal to half of kg jam density and half of free speed. Okay. So, if I got jam density as 160 by 2, 80 and free speed is how much? 65 by 2, 40, you will get 2600. So, vehicles per hour. Because these you can write, my dear students, jam density is given, okay, density is nothing but vehicle per kilometer and we have, this is vehicle per kilometer and this is also kilometer per hour speed, okay, kilometer cancel, you will get the answer as vehicle per hour. Is it clear, sir? Can you quickly answer me? Is this clear for everyone, my dear students? Okay. Now, please read this question, my dear students. It is a question related to railway engineering. So, I will give you 1 minute of time. Please read that. I will give you 1 minute of time, my dear students. Okay, please read that question. And I want you to please comment. Please read that problem and anyone, can you please try? I'll give you 1 minute of time. You have a question here. A broad gauge railway line passes through a horizontal curved section. Passes through a horizontal curved section of radius 875 meter, of length 200 meter. Allowable speed on this portion is speed on this portion is 100 kilometer per hour. The allowable speed on the portion is 100 kilometer per hour. For calculating the cant, consider the gauge as center to center distance between the rail heads equal to 1750 mm. The maximum permissible cant in mm round off to 1 decimal place with respect to the center to center distance between the rail heads is. He is asking indirectly the cant means it is nothing but banking or super elevation. Is it clear, my dear students? So we have given, they have given you clearly, my dear students, the radius is how much? The radius is 875 mm. The radius is given 875 mm. And the allowable speed is 100 kilometer per hour. The allowable speed is 100 kilometer per hour. And they also given you the gauge length, that is 1715 meter. Okay. Radius is how much, sir? It is because it's a broad gauge. Sorry, it's a broad gauge. So the length is standard. The gauge, broad gauge means you can say broad gauge. So the length is 1750 mm or 1.75 meter. Now, what is the allowable cant? Allowable cant is given by the formula gradient upon allowable square upon 127R. So here I will tell you very simply, my dear students. Actually, when you talk about cant or E, we also know that it is V square upon 127 square R. But in railways, we talk about different gauges, no? So here G will come into picture because G VL square by 127 R. And here V is in almost, my dear students, V is always in kilometer per hour, when it is 127. So G is 1750 mm. V square is how much, my dear students? It is 100. How much they have given? 100. 100 square upon 127 radius is 875. 875 means it is almost 2, my dear students. Okay. So 2 into 10,000, 20,000 divided by 127. What is the value? It will be equal to almost 157.66 mm. And remember, my dear students, here, whatever the gauge you have taken here, it is mm, you will get the answer in mm. If you have taken this in meter, gauge distance, you will get the answer in meter. Why? Because here, if you talk about the cant, usually it is a ratio, it is a slope, so usually don't have the values and it takes the value of the gauge only into consideration. Is it clear, my dear students? Okay, another beautiful question, Amma. I want everyone to see this question, my dear students, and it's the important questions, and I want you to go through this question. I'll give you 2 minutes. This time I increase the speed time. I will give you 2 minutes of time. Can you quickly answer me? Read the question carefully first. First read the question, my dear students. Everyone read the question carefully. Okay. Is this clear, my dear students? I hope 1 minute is more sufficient to read the question and to get an idea. The speed density relation of a highway is given by the formula U is equal to 100 minus 0.5 k. This itself you can understand, my dear students, where U is the speed in kilometer per hour, K is the density in vehicle per kilometer, and what is the maximum flow? What is the maximum flow is asking. So here, my dear students, U is given as the equation of what, my dear students? 100 minus 0.5 k, right? You told me clearly one important relation. The free mean speed is given by the formula UF minus K into UF upon Kj. Are you getting me? From this equation, UF is taken as 100. Free mean speed is taken as 100. Now, my dear students, here you have clearly taught me 0.5 k. So UF by K, UF by Kj is equal to 0.5. Are you getting, my dear students? From this UF is 100. 100 divided by 0.5 is equal to Kj. Now from this, jam density is equal to 200. See, my dear students, if you can understand the formula and derivation, this problem is nothing. Now what is the maximum flow? What is the maximum flow? UF or VF, free mean speed, into jam density upon 4. So you can write here UF is 100 and Kj is 200 divided by 4. So this will be equal to, flow is 5000 vehicles per hour. Yes or no? Is it clear, my dear students? You got the answer also, 5000 vehicles per hour. But remember, my dear students, this is a important logic. If you don't remember this, you cannot solve. And one more thing I told you, my dear students, I am telling you again and again, when these are very important problems, my dear students. When I draw a graph between speed and density, you have seen clearly the free mean speed. This is the free mean speed, is given by speed minus of speed into, it varies according to the ratio of K by Kg, which is maximum Kj. So from this equation, he has clearly given 100 minus 0.5 K. So it is evident that UF is 100. When UF is 100, 0.5 indicates UF by Kg is 0.5. So from this, Kj is equal to 200. And I don't want to derive again and again. You know, maximum flow is equal to UV, free mean speed into Kj upon 4. So this is what I want to tell you. Is this clear, my dear students? Is it clear, Amma? Is this clear? Is this clear? Okay. So from that, it is 100 into 200 divided by 4. That is easily 5000 vehicles per hour. Now read this question, my dear students. Read this question carefully. Now, see students, I will read the question for you. Given the following data, design life N is 15 years. The design life N is 15 years. Lane distribution factor, we call LDF, lane distribution factor, is 0.75. And annual rate of growth of commercial vehicles is 6%. Now, my dear students, in a simple interest or compound interest, sorry, not in compound interest, we have a formula called P plus 1 plus R power n, where R is the rate of interest, where P is the principal amount. From these, they have given number of life, that is 15 years, and they will give you initially how many number of vehicles, and they have given how much it is going to increase the rate, that is 6%. Vehicle damage factor is also given as 4. The vehicle damage factor is also given as what, my dear students? Vehicle damage factor is 4. Initial traffic is given. Initial means P, that is principal, like we can take principal amount here. Initial traffic is how much, my dear students? The initial traffic is 3000. Am I clear? Are you following, my dear students? So, this is 3000 commercial vehicles per day. As per Indian Road Congress Code, the design traffic in terms of cumulative number of standard axles, that is million standard axles, is asking in million standard axes. Is the question clear, my dear students? Is this question clear for everyone? Is this question clear for everyone, my dear students? So here, if I see here what I would like to tell you here is, okay, just see the important terms here. Vehicle damage factor is there, lane distribution factor is there, and also we are going to discuss about the principal. Initially 3000 vehicles and they are increasing at 6%, my dear students. So from these, how to find out the cumulative number of vehicles? See, I told you amount is equal to what? Simple concept. See here, my dear students, when I talk about amount is equal to principal into rate of interest power n. This is what amount will tell you. This is what amount will tell you. Now see, students, see here number of standard axles is 365A. See, my dear students, here 365A, that means you can say 365 days into A means amount, which I told you, P or he has given amount as 3000. So here the rate of interest is also considered the A, or you can take it as P, my dear students. 1 plus R power R by 100 means anyhow percentage is given, power n minus 1 into, this is vehicle damage factor and this is lane distribution factor. Now, my dear students, into 10 power minus 6 is, he has asked the answer in million standard axles. Million means 10 power 6. So, we are calculating million, and here it is 365 because in year, and A is the means initial, and 1 plus rate of interest formula, my dear students. I usually told the students usually in this way, upon R by 100, that is 6%. That itself they will give you in R as rate of interest, students. So if you solve this problem, so vehicle damage factor is 4 and you can say lane distribution factor is 0.75. Actually, the lane distribution factor and vehicle damage factor will also vary, my dear students. Here you can remember that like A or P, 365 means it is number of days, 1 plus R by 100 power n. Okay. See, my dear students, 1 plus R by 100, that is common, my dear student. Sorry. Minus 1. Okay. Upon R percentile, or you can write R by 100 into vehicle damage factor into lane distribution factor. In this way, you will calculate the total number of axles. And remember, my dear students, you are multiplying with 10 power minus 6 because he has asked in the problem clearly million standard axles. If he has not mentioned the word million standard axles, you cannot solve this. You cannot, you need not to multiply usually, but the answer they usually ask in million standard axles. That is the reason We will multiply this. Are you getting, my dear students? So usually in million standard axles, when they ask you in million standard axles, we multiplied the value with 10 power minus 6. This 10 power minus 6 indicates million standard axles. Any doubts, my dear students? Any doubts? Okay. Now, this is another important question, Amma, in traffic. This is another important question in traffic. Please read that question. Here the thing is, the traffic volume count has been collected on a two-lane road. On a two-lane road, which needs upgradation due to severe traffic flow condition. Means it is a two-lane road and it requires severe, there is a severe traffic flow condition. What is the maximum service rate flow observed as? The maximum service flow rate observed per lane is 1280. The maximum service flow rate is observed as 1280 vehicles per hour. It is observed as 1280 vehicles per hour. The peak hour factor is reported as 0.7825 and the historical traffic count provides annual average traffic as 12270. Like you can say 1,22,270 vehicles per day. And the directional split is observed to be 60-40. Means the vehicles can move one in one direction and other can move in other direction. Assume that traffic consists of all cars and all drivers are regular commuters and the number of extra lanes round off to the next integer. You have to consider the number of extra lanes. So here I would like to tell you again, my dear students, you should understand again here the question. So I'll give you another 1 minute to read the question for everyone. First read the question very clearly, my dear student. If you read the question very clearly, you can understand it. Now, okay, my dear students, I hope you are clear in the question. He has given clearly the traffic volume has been collected on a two-lane road, which has to be grown for upgradation due to the traffic flow condition. The maximum service flow rate is 1280 vehicle per hour and the peak hourly factor is 0.78125 and the historical traffic provides annual average daily traffic, that is 12270 vehicles per day. Directional split is 60-40 and what should be the extended lanes you should solve. Okay. Now, my dear students, he is asking what is the number of lanes to be given. So, here we have a formula, my dear students. The formula is very clear. The formula is, I'll tell you what is DDHY upon PHF into MSF. Sorry. I have written those values also clearly, don't worry, my dear. MSF into FHV into FP. Okay. Now, what is DDHV? First of all, directional distribution hourly volume. DDHV is directional distribution hourly volume. What is PHV? So peak hour factor. What is MSF? Maximum service flow rate. MSF is nothing but the maximum service flow rate. And what is FHV is heavy vehicle familiarity adjustment factor. Means you can say due to heavy vehicles there should be some adjustment. Is it clear, my dear students? Is it clear? Okay. Now this FP, road user familiarity adjustment factor. One is heavy vehicle adjustment factor and another one is road user adjustment factor. You can write in FP, and this FHV is the heavy vehicle distribution factor, familiar adjustment factor, maximum service flow rate, MSF. DDHV is directional, you can say directional distribution hourly volume. So you know everything, my dear students. See here why I have multiplied with 0.6. He has given clearly in the problem, my dear students. The split is given in 60-40 ratio. So whenever there is a split given, you have to multiply with 0.6. Okay. When I multiply with 0.6, sorry, in the question it was given as 12270, but it is 12270. Here it is 12270. 12,270 vehicles per day. If you multiply with 0.6, you will get 736. So we have given everything. So here it is simple, Amma. What I would like to tell you is directional distribution hourly volume is multiplied with 0.6, you will get 7362 multiplied by 0.7825, or this is nothing but the multiple. What is 0.7825, my dear students? And what is heavy vehicle familiarity adjustment factor? And then we have the heavy vehicle familiarity adjustment factor and road user familiarity adjustment factor. By applying those things and applying this formula, you will get 7.3762 lanes. But remember, my dear students, he is asking what is the number of, so actually number of lanes, if you calculate, you will get some 7.3. So it should be round off to the next lanes. So the number of lanes is 8 lanes. But he is asking what is the extra number. This, sir, most of the students who have done the GATE exam, they have done this. Up to here, everyone has done the problem and they have done the wrong. Here, I would thank you, Vipin sir and Nikhil sir. What I would like to tell you here is, when I provide you the extra number, the total number of lanes here is 8. 8 minus 2, you can say it is 6 lanes. Because 2 lanes are already provided. Sir, my dear students, you feel these things are very simple, but everyone will write the answer 8 if there is an option. But he used the word extra. Extra means already 2 lanes are there. But when I say the extra number of lanes, it is 8 minus 2, that will be equal to 6 lanes. Is this clear, my dear students? Is this clear? Now, my dear students, I would like to tell you very important points according to the transportation in my experience. So I would like to prepare every student, means I want my every student of IMS GATE Academy and the real aspirant of GATE to please go through the geometric design. Okay, when I talk about geometric design, you should understand what is stopping side distance. If the formula is lag distance Vt plus V square by 2gf, this we call it as F plus or minus n. V is called, I told you, the velocity in meter per second. This is called lag distance and this we call it as braking distance. And n will be positive in ascending gradient when you are moving to lower to higher, and it will be negative in case of this gradient. So this is stopping side distance. Similarly, OSD, yesterday I have given you D1 plus D2 plus D3 for two-way traffic, and if I take about one-way traffic, D1 plus D2. Similarly, you can ask me extra widening. Extra widening is given by NL square by 2R plus V by 9.5 root R. So when we have the curves also, transition curves En by 2 into W plus WE extra widening. So what I would like to add here, my dear students, first of all, you should be very clear in geometric design. No, my dear students, as far as I have observed, if you are able to remember all the formulas in geometric design, most of the questions will be solved. Just try to solve the previous year gate questions and remember the formulas. And one more suggestion, my dear students, when you are remembering the formulas, my suggestion is to remember the formulas in meter per second. Don't try to remember in kilometer per hour, because when you remember in kilometer per hour, you have to remember the fraction also 0.278. That will be very difficult for you. So please try to remember the formulas of geometric design. Now, apart from that, when I talk about traffic studies, when I see the traffic studies also, I told you the graphs, my dear students, the graphs between flow and density, the graph between speed and flow, the graph between speed and density. These are very important, my dear students. If you can remember these graphs and this equation, Q max is equal to Vf into Kj by 4, jam density. And also if you can remember the free speed, that formula Uf minus K upon Kj into Uf, if you can remember these things, and also the formulas which I told you, the problems, standard problems, and the vehicle damage factor problems, and there are also called related to the delay time, which we have discussed also. Delay time is equal to C naught by 2, 1 minus Gi upon C naught of cycle length whole square upon 1 minus Qi upon Si. Natural, normal flow, saturation. So these things will make a lot of difference. Apart from this, when I talk about railway, this is very important. As I told you, a cant usually they ask you 127 hour. So remember, my dear students, whenever you are preparing transportation, previous 20-year questions, not solving previous 20 years questions, you have to prepare your short notes and you have to come up with formulas. Okay, you have to remember the formulas, because there are a lot of formulas, and if you can remember some formulas, you can save the time also. So this is how you can get marks. And in this year, I am expecting almost 6 to 8, minimum 8 marks I am expecting. And this is my wild guess, my dear students. You will get for geometric design, I am getting 4 marks. Traffic, you will get either 4 marks. Here you will get 2 marks, or here you will get 2 marks. But you will also get from flexible payment or railways or airport. From all these things, my dear students, another 2 marks. So this is what I would like to emphasize on GATE. And remember, my dear students, if you are really an aspirant of GATE, please, my sincere request for all of you is, please read all the previous 20 years questions and prepare your short notes. And remember, if you feel that they are difficult, you make that notes as your WhatsApp status, or you make it as a screensaver, or you stick it to your room. In that way, daily if you look at those things, you will definitely improve. I hope you have enjoyed the session related to transportation, and really I'm really excited you to see coming with good colors after seeing my videos related to transportation. And one more important thing I would like to tell you, my dear students, this is all about the IMS GATE Academy. Our institute has already, we have proven a track record of 11 years, and we have got very good results because of continuous dedication and continuous efforts in making good questions, quality content, quality teaching, and all these made us to enroll to get the students in good ranks. So it's not about a student who has not only means, remember, again and again I am telling you, my dear students, don't think GATE is not is a so difficult exam, because as per the stats, around 1 lakh students are appearing for GATE, means only 10,000 students are qualified. So this makes a lot of difference, my dear students. This makes a lot of difference. So please understand this point, and you are competing with these things. In IMS GATE Academy, we provide classroom program. We provide hybrid classroom program. What is hybrid classroom program is we provide both the offline coaching as well as the online coaching. We provide both offline and we have the exclusive live online program. Remember, my dear students, when you are running the online program, how the doubts has to be explained. We have a beautiful system in IMS, that is one-to-one mentorship. A faculty will be assigned to 3 to 4 students and they will be monitoring the students, and they can contact the students can contact that faculty for doubt solving and all those things. But if you want to get the price at an affordable price, at low price, you can go with the self-learning program also, where you can enroll with us with IMS GATE Academy, where all the recorded sessions and everything will be available. Now coming to the classroom program, my dear students, 750 hours of offline classes have been provided at Bangalore. We at Bangalore in Jayanagar were providing the complete online, my dear students, without any online sessions. At Bangalore, we are the only institute, we are giving 750 hours with complete all offline course. So this is entire offline, I would like to tell you, my dear students, because the students who are really want to get into offline, you can come into the Bangalore center and you can get in touch with us. And we provide 20 to 30 books, and we have theory books, exercise books, gate question book, doubt solving portal. This is very important, my dear students. See, theory books covers all the content of each chapter. We have an architecture for every subject. So how the questions has been asked. We have done some permutations and combinations. What should be the best possible material we have come up. This doubt solving portal is very important, my dear students. How the doubts has to be explained, how the doubts can be explained in video solution, how it can be explained in a paper. Definitely it will be answered within 24 hours of within 24 hours of time, the doubt will be answered. And we also have my plan strategic sessions. What exactly is my plan strategic sessions is, whenever any doubts or anything, some people feel difficulty in mathematics, some people will feel difficulty in core subjects, some people unable to concentrate, they require some motivational sessions. So according to the convenience of the students, according to their time, we will be available in the offline center as well as in online to continually monitor our students through the my plan strategic sessions. And at IMS GATE Academy, we provide test series, chapter test, subject test, multiple test, full length test, and post guide interview. So whenever related to the any test, so students, you should understand the test should be very crisp, and at the same time it should cover all the topics. It should not be like one topic there should be excellent more number of questions. So we have done that permutations and combinations, and we have come up with this. In a hybrid classroom, 2/3 will be offline classes. We are providing this hybrid questions even at Vijayawada center. Vijayawada is one of the beautiful center because we have very good number of students, and the students who are really interested in the area of Andhra Pradesh or who are near to the Vijayawada center, we are providing 2/3 of the offline classes. If the student is really interested for offline at Vijayawada, this IMS is the right place, because this is the only institute which is providing 2/3 of the offline classes, and I can say no other institute in India at Vijayawada is providing no other center at Vijayawada are providing offline. Even at Ahmedabad also we are providing this offline, and we are having theory books, exercise books, gate question book, DOBS. The same thing what we have followed in all the pre-record means the offline coaching, everything. And here you can see 2/3 of means almost 400 to 500 hours of offline will be provided, and that offline coaching will be more on the important subjects and how they will be delivered, and all those things is very important for the student point of view, because the student feels that offline is more important, and I feel that offline has given good results for the students. When I come across exclusive live online program, we have come up with 750 hours of live program. See students, when the students are offering online means that is an important peculiar case, because when they don't have any access to the offline centers, especially for IMS GATE Academy, students are feeling with they want to touch with the online center. So same whatever we provide in the offline, we are going to provide in online, and in the online presence We have a separate platform where the doubts can be asked, where a limited number of size of batches will be there. We have evening batch, morning batch, and also we have a customized batch for all the students who are regularly preparing for GATE exam. So all these things we provide the same theory books, doubts portal, and my plans, and every notes will be provided after every sessions with using the PDFs. So even the notes when we are explaining in the online, the student has the ability to, the student need not to worry, is has to just listen, because the notes will be emailed to the respective teams. Self-learning program is somewhat less costly, and we are giving just 400 plus hours of live. But one of the beautiful thing of IMS GATE Academy is you can access one subject with different faculties. That is the most important point I would like to add. And we can follow wherever, if we want to success in your life for any competitive exam, practice, learning, practice and test is very important. And we have a beautiful questions, my dear students. AMS All India Mock Test Series, these tests we are providing freely to all the real GATE aspirants who are, in the description link we have given the free zero fees program as well as the MTS. You can visit our website and you can go through, register there, and everything will be freely available for this. And remember, it has taken 1 year of valuable time to prepare the best questions to fit for the students who want to have been in the single digits. So this is what I would, that is the thank you, Amit. So here I would like to tell you what should be the subject wise test. What, see how the questions have been asked in GATE, like there are 2-3 subjects combined one question, and there are some things where we are asking particular chapter and we have full length tests. You should be habituated for 3 hours. So based on different combinations we have come up with chapter test, subject wise advanced level test, multiple subject, how the question can be very, thank you Ajay. When they want to, how the subject has to be connected, all those full length mock test, everything we are taking care. So this zero fees program, my dear students, I promise you no other institute will give you 100 plus hours just for free. You have to just visit our website and you can register. You'll get 100 plus hours of free course, and 12 chapter tests. You will get 6 subject tests, 6 past GATE papers. So this is a lot for free of cost, and no other institute provides you this many hours of free. So you can enroll with us at zero fees if you are real interested. So this is our student portal, because if you see the geotechnical, there are 94 lectures, 22 e-books, 13 e-tests. Like you can access 2-3 people at a time. So this is our student portal, doubt portal. Okay, these things you can understand, my dear students. See, my dear students, one-to-one mentorship. What is one-to-one mentorship? See, students, when you are preparing 60 days to the GATE exam, what subjects you have to prepare, and if you are really good in mathematics, how best you can get the score. Suppose if you see aptitude or mathematics, they are very easy subjects when you compare to an engineering graduate, because everything comes under maths and aptitude. So if you practice, definitely you will get easily 25 marks, and you can easily score 25 out of 25. But the scoring really helps in the core subjects. At that time you should be very careful, because maths and aptitude, every engineering student will get good marks, because he is the real aspirant, because he is a real because everything depends upon maths. Okay, and I hope you have enjoyed this session, and whatever we have discussed in the transportation part, please concentrate on the topics, and I hope you have enjoyed this session. If you really enjoyed this session, please like and share this session. And if you have any really doubts or anything, you can just contact our website, and definitely all your questions will be answered in that website. Okay, thank you one and all the best for your GATE exam, my dear GATE students. And I really thank all the civil GATE aspirants who are watching this video, and it will help you to some extent to understand the problems in an easier way. And again, my dear students who are real GATE aspirants, please be dedicated, stay tuned, and utilize these 60 days in a very informative and a very calculated way. And I hope these sessions will help you. And in IMS GATE Academy, in the GATE score booster, our intention is to provide all the questions in such a way that all the topics are covered, and we have a very good team. So you can visit our website and you can collect all the information. Thank you one and all the best for your GATE aspirants. And in the next week we are in the coming days 15th we have an excellent faculty, Mr. Ankit Dongrial. Ankit will be handling the geotech. I really request everyone, don't miss this geotech. Ankit will make you the session very interesting, and I will ensure that he will give the best out of geotech, and after listening the geotech class you will be at least confident. Thank you one and all. Thank you and all the best for GATE aspirants.